So, looking at number 5, um, if we want to look at where the horizontal asymptote is, remember we can compare the exponents and they're both 2. All right, so if they are the same, that means basically as x goes to infinity, these are the same, so they don't matter. So y equals 2 is our horizontal asymptote. All right. Then if I want to know the discontinuities, all right, where there's a whole or a vertical asymptote, you need to factor. All right, so I'm going to look at this right here. I'm going to, they both have a factor of 2. So I'm going to factor that out, and then I have 2 times x squared over minus 4 over x squared. All right, and then now the x squared minus 4, I can factor that again. And so I get 2 times x plus 2 times x minus 2. And then that's over x squared. All right? So I can see my vertical asymptote there is going to be where x equals 0. All right? Because that is what makes my denominator be 0. Right? The vertical asymptote is if you're dividing by 0. And as far as a whole, there is none, because I don't have the same factor in my numerator and denominator. All right, they're all totally different. So there are no wholes. And the x-intercept is where y equals 0. And to remember to get my function to be equal to 0, right, y equals, I need a numerator that is 0. All right, so that's like, remember y equals okay. It's okay to have a 0 in your numerator. That just means that y equals 0. Okay. So what value of x is going to make my numerator 0? So now I'm looking at these factors that are in my numerator. All right. So if x is negative 2, that would be 0, and if x is positive 2, that would be 0. So those are my 2 x-intercepts, positive 2, 0, and negative 2, 0. All right, and then my y-intercept is where x equals 0. All right, for my y-intercept, x is 0. And if x is 0, again, I'll go back to my function. If x is 0, this is 0, this is 0. Oh, and I'm dividing by 0, right? So that would be a problem. Remember, x equals 0, that was my vertical asymptote. So there is no y-intercept. It's not going to cross the y-axis. That's it. The y-axis happens to be my vertical asymptote. Right? This is x equals 0. That's the y-axis. And then my domain, all right, it's probably a good idea. For domain and range, I like to look at the graph. So let's go into Desmo. Okay, so I'm looking at this function here, and it's this kind of cool shape. It looks like a funnel, right? And if I'm looking at what my function is, well, for the domain, it goes, everything's fine, right, from negative infinity. Everything is fine, right, until we get, remember, x equals 0 is my vertical asymptote. So I go to negative infinity, I have to lift up my pencil so it's discontinuous, and then I pick up from 0 again and go to positive infinity. All right, so these are my 2 intervals, negative infinity to 0, and then from 0 to positive infinity. All right, and that's the domain because I'm looking at the x's. Okay, so my domain is going from negative infinity to 0, and then it picks up at 0 and goes to positive infinity. In words, that would be all real numbers, except x cannot equal 0. All right? That's more of like set notation. Right now, if I'm looking at the range, I'll go back to my graph. Okay, so I'm looking at my graph here, and it's going from, you always start from the lowest, right, the bottom to the top. So it goes from negative infinity, right, both of these went down to negative infinity, and I'm going up, and then it levels off here, it approaches, and this is my horizontal asymptote. All right, it approaches as I go from negative infinity to positive, as I go up, right? So I'm starting at negative infinity and it's going to 2, right? Y equals 2. Remember that was my horizontal asymptote, right? Because my two exponents were the same, right? So that cancels out, and so you get y equals 2. That was my horizontal asymptote because that's 2 over 1, right? You look at the coefficients here. And you see how it levels off there. To get your horizontal asymptote, you just look at this is your end behavior. Right? Your end behavior always tells you your horizontal asymptote. Hey, y equals 2. Okay? And again, if I'm describing my end behavior, I could say as x approaches negative infinity, right? That's going on, this is on the left-hand side. F of x is approaching 2, right? And then if I look at the right-hand side here, as x approaches positive infinity, right, going here to the right, my function is approaching this horizontal asymptote. It's approaching 2. Okay, and remember that is end behavior. When we say end behavior, we're talking about this phrase right here. All right, end behavior is this. Okay, excellent. So my range goes from negative infinity to 2. All right, so I'll write that down, from negative infinity to 2. All right, and both of those were the same. So there's only one interval, or you could say all real numbers, the set of all real numbers, except y is not equal. Oh, actually, y is less than. Actually, I can say all real numbers then. All right, I'll just do that if there's only one number that's not. But for this range, I'm going from negative infinity to 2. That would be y is less than 2. Right? If I'm doing set notation. Okay, excellent. Good job.